This is an introduction to graphing. So as we start this new unit, as we go throughout the whole time, the purpose of what we're doing is going to be to try to learn to effectively graph lines. Try to take relationships and depict them and understand what each part of them means and what every point means and what every value means, and so that you can answer questions and not only take text and put it to a graph to answer questions, but you can also take the graph and then put it back into text and explain into words what happened according to what you're seeing. As I started thinking about how I wanted to start off this unit, I kind of wanted to start off where I'm going to end. So we're going to end up in word problems, talking about real-life situations and trying to figure out exactly how to take real-life situations, turn them into graphs, and use that to answer our questions. But thinking about graphing, it's something that is so natural to so many of us. We see it all the time. So you might, if you watch SportsCenter, you'll see a graph all the time. Or if you watch the stock market, or if you watch your bank account, or anything, you see graphs. And so it's something that I kind of wanted to start off with the word problem so we could see what the relationship is and how significant it is, and then go from there to fill in some of the guts of why are things happening and the technical details that are so significant that are going to be really useful to helping us really utilize the math. So I started off with a word problem. This is a true story. My friend Kaylin owns her own apartment in Harahan. She was living by herself with an extra bedroom, but at one point she decided to rent it out to her friend Christina to make some extra money. If Christina pays $450 a month, so I'm going to circle that because that's important information, and Kaylin currently has $2,250 in July, when will she have $4,050 in profit? When did Christina move in? So there's two questions here. Question number one, question number two. When did she move in? Graph the relationship. So as we start looking to plot, to try to get a line, the first thing we have to think about is what is the relationship? Well, in this case, I gave it to you. It's the relationship between months and profit, right? So in order to put a point on there, I need to know how much profit happens at a specific month. Well, typically people read this first, just because it comes first, and so they go, oh, $450 per month. I'm going to put that on my graph. I'm going, you don't know where to start. You don't know what to do yet. You don't know which month corresponds to $450. You know that that's the increase. But you do know that in July, she had $2,250. So I'm going to go ahead and sync up July with $2,250. It's about right there, about right there. I'm going to put a point. All right? Now, a different way of representing a relationship beyond a graph is to look at a table. And tables and graphs usually go hand in hand. So I actually put one below so we can look at it real quick. In July, you've got $2,250. Now, according to the story, she makes $450 every single month. So that means if she had $2,250 here, she's going to make $450. And so that will put her at $2,700. And then she'll make another $450 every single month. $450, $450, $450, $450, etc. So then she goes to $3,150. Makes another $450. $3,600. Makes another $450, $4,050, which is the number we're looking for, which for the sake of finishing the graph, we can keep going to find out that in the last month, in December, she's going to have $4,500. And so I can go back up to my graph and I can graph that. I started off here. I go up $450, will put me somewhere about here. Up $450, put me somewhere about here. Up $450, put me somewhere about here. And I know that my December is going to end up right at $4,500, so end up right about here. So then this one needs to be here, and there we go. So now I see a line coming out of this, right? And I can answer the first question. When does she have $4,050? She has that $4,050. If I go down to my chart, I see that it shows up in November. So that's the first thing. The second question asked, when did Christina move in? She started off with $0. She made $450 until she got to this point. So in order to do that, we have to go the other way on our chart. We have to go back to June. Well, if she made $450 every month, that means the month before she was $450 poor. And so if I take $2,250 and I subtract $450, I end up with $1,800. I subtract $450 and I end up with $1,350. I subtract 450 and I end up with 900. I subtract 450 and I end up with 450, and I end up with 0. Now, as I go to plot those points, I'm going to subtract. I know that I'm going to start off in February at $0, and then go up $450 a month, which is almost the whole line, until I get to where I was. Now, I'm not super worried about the accuracy of the points and the accuracy of the line and the accuracy of the details. It was kind of just an introduction, but I did want to look at it. So I know that each of these points corresponds to a specific relationship between the month and the amount of money. Right? So it's really important that as we start graphing that we remember that the points aren't just random things, but they hold specific relationships. And so we can see that. And moreover, once we go in and we find out why we're doing the things that we're doing, and we explore some of the guts of graphing lines, and how do you do it, and what are some of the terms, then we can discover some of the more powerful stuff that, if I took this chart, I would have to stretch it out if I wanted to find out how much money she would have after 700 months or 7,000 months. But if we understand how lines function and how to come up with a linear equation, we can skip a lot of that step and do it in 30 seconds. So I thought that it was good. We're going to start here, and now we're going to go back and we're going to fill in some of the guts. We're going to talk about plotting points, and each point is a specific relationship. We're going to talk about intercepts. We're talking about slope. We're going to talk about all different kinds of things, systems, piecewise functions, etc., etc., etc. So I hope that was a good introduction. Now rolling into the actual first lesson. The first lesson is an introduction to graphing. The Cartesian coordinate plane is formed when two perpendicular, so perpendicular means meets at a right angle, two perpendicular number lines, perpendicular number lines intersect at their 0 points. They come together to form a grid made up of 4 quadrants. And so now we're going to go around and fill in some of the rest of our vocabulary here. The up and down line is called the y-axis. The left and right line is called the x-axis. Now I go around. I've got 4 quadrants. 1, 2, 3, 4. Top right one is going to be my first one. Quadrant 1. Now I know it seems like a little detail, but make sure that you use the Roman numeral for 1. Doesn't seem like it's that significant, but it's one of those things that if you start a conversation with somebody and you write down quadrant 1 and you use like the traditional number 1, they're going to look at you a little funny, especially if it's a future math teacher. So make sure that you pay attention to that. Over here I have quadrant 2. That's everything left of y and above x. Bottom left I have quadrant 3. I'm just going to put a 3 and roll on. And finally, bottom right is quadrant 4. This is usually the point where I get the question of, why is it go in this order? And to answer that question more, I'd really have to talk about trig. You'll get there when you get to advanced math, but for now, just trust me on it. The last thing is, there's a blank here that points dead to the middle, and that point is called the origin. Now, just like in traditional English vocabulary, origin means that's where you start. And that's exactly what it's going to mean as we go about working our problems. The first definition we have on this page is an ordered pair. An ordered pair is a set of numbers which describe a specific point on a plane. It's labeled x, comma, y. Now, in the past I've had people who have trouble remembering which one comes first. Is it x first? Or is it y first? It's always alphabetical order. When I tell people that, it tends to help them remember. It's always alphabetical order. And more importantly, I want to stress that an ordered pair is a relationship between two independent numbers, two independent quantities, right? So it might be months and dollars, or it might be number of pairs of shoes sold and amount of profit. I mean, and it could be anything under the sun, but is a specific relationship between two independent quantities. Looking at a point on the coordinate plane, how do you do it? The first step is you got to begin at the origin. Like I said, origin is where you start. Your second step is to move left or right the specified distance along the x-axis. The third step is to move up or down the specified distance along the y-axis. I was talking to somebody earlier today, and they were telling me about how they used to have trouble remembering whether to go left or right first or up or down first. And their teacher told them, imagine that you're trying to climb a ladder to get to a point. You have to move the ladder over before you can climb it. You can't climb it and then slide over once you get there. So that helps them remember to go left and right first and then go up and down. Whatever works for you, as long as we can make sure that we can graph these points. So as we look at our graph, the first question is, what are the coordinates of point A? So locate A, there it is. I know that I have my origin right here. I'm going to start off at my origin. First question is, if I'm going straight to A, how far left or right do I have to go to get there? And the answer is, I don't. So I'm going to put 0 as my x. The second question is, how far up or down do I have to go? Well, I have to go 3. How far, do I go up or do I go down? I go up, and so then I know that means I'm going to be traveling positive 3. If I move up, I'm going positive. If I move down, I'm going negative. If I move left, I'm going negative. If I move right, I'm going positive. It's very, very, very important that as you start labeling ordered pairs, that you put parentheses around it and a comma in the middle. And all the time I hear, but Mr. Copeland, I had the right answer. I just missed the parentheses. If you missed the parentheses, you didn't have the right answer. But I totally had the right answer. No, you didn't. If you didn't have the parentheses, you didn't have the right answer. Because the right answer has parentheses in it. So make sure that you remember to put those parentheses around there. It will make your answer wrong. What quadrant is this point, point A, in? Now, you're going to dive deeper into some technical definitions in geometry. But for now, I'm just going to leave it at this. You see this point A here, and it's this giant black dot. And if you look at it, you would think, well, half of it's in quadrant 1, and half of it's in quadrant 2. So it's in quadrant 1 and 2. But once you get down to more technically defining a point, you realize that a point really isn't this big around. I could have made the dot even bigger, but a point has a very, very specific location, and it actually has an infinitely small width. So as you dive in and zoom in and zoom in and zoom in and zoom in, there's actually none of this point that's over here, and there's none of this point that's over here. It's totally sitting on the y-axis. So it's a little bit of a trick question. I say, what quadrant is it in? And the right answer is, it's not really in one. What are the coordinates of point B? Well, point B is right here. So I start off with my origin. I travel to the left, 1, 2, 3, 4, and I travel on the left means that I'm going negative. And then I go up, 1, 2, 3, 4. Negative 4, 4. What quadrant is it in? It's in 2. Plot the ordered pair 2, 0 as the point C. So I go to 2, which is here. And then I go up or down, none, and so there it is. 2, 0 is my point C. What quadrant is it in? Well, just like before, it's not here, nor is it here. It's actually on the x-axis. Lastly, plot the ordered pair negative 3 as a point D. So I go to left 3, I go down 3, I put my point, there it is. I put my D, because I got to make sure that you label all of your points. And what quadrant is it in? It's in 1, 2, quadrant 3. So as you start working on assignments from here, you need to be conscious of a couple of things. Number one, can you go from me giving you points and you finding the ordered pair? And number two, can you go from an ordered pair to you plotting? Right now, you're going to see on this graph, I go 1, 2, 3, 4, 5. But sometimes you're going to see graphs that go, they skip and then they go 1, and they skip and they go 2, and they skip and they go 3. And they got half increments. And sometimes you might see a graph that goes 2, 4, 6, 8, 10, or even 10, 20, 30, 40, 50. And so as you start working on different graphs of different kinds, you need to make sure that you're thinking about scale, because scale is going to come up super important later. So hope this was helpful, and thanks for watching.